So in this course, I'll discuss the IT supply chain security followed by deploying Linux updates and configuring a Windows server that is WSUS host. Next, I'll discuss the object-oriented program, otherwise called as OOP, and how this relates to insecure decentralization attacks. Moving on, I'll ensure file integrity using file hashing on both Windows and Linux. And finally, I'll use the OWASP dependency check tool to verify the publicly disclosed vulnerabilities that are present in a project's dependencies. The CIA Triad has been a long security staple in the IT world. The CIA Security Triad consists of three security items. The C stands for confidentiality, I for integrity, and A for availability. Now, this is all related to OWASP Top 10 Item A04 for 2021 version, which is labeled as insecure design. So certainly making sure that the data is confidential, so kept from unauthorized eyes, making sure that it can be trusted, so verifying its integrity, making sure it's available when it's needed. All of this is a part of the secure design and overall web application, and these items need to be considered. But let's go and see more in detail. So let's start with confidentiality. Now, often confidentiality comes in the form of encryption, which we are encrypting the rest of the data in transit. The idea is that we might have a certain contractual or regulation, obligatory compliance requirement that requires us to meet a certain security standard, such as encrypting with the stored on the disk. The other thing about this is, of course, the goal is to prevent unauthorized disclosure of sensitive information these days. Data privacy is a very big deal for organizations and government agencies. Alike, and we want to make sure that who has access to sensitive information, and that of course they are authorized to do so. So this applies in storage, where we are storing data in the cloud, where we are storing data in thumb drives, hard drive, laptops, wherever the case might be, as well as network encryption as well. So so storage encryption could also come in the form of things like encrypting file system or BitLocker encryption in Windows. You might want to use a network encryption in the form of ensuring that HTTPS binding for web application or VPN to connect to a private network over the internet. Maybe using an IPsec for LAN connection to secure all the traffic. There are many different options like this. So in confidentiality side, the web application, as we know, can apply to data encryption at rest, whether it's in the cloud or it's at the premises, or you have to think about only assign the permissions required to perform a specific task. So we don't want to give any more permissions that they are needed, and this means that we would be adhering to the principle of least privilege. We want the a role that must be like a group. You would have a group of role that would be assigned permissions to it. Whoever is the member in that role, the group would have these permissions. You might also be using the claims, where the assertions about the user of the device, like the date of birth or subnet or the device, like that. If an application needs to consume that to allow the access to the application. And of course, we know that we should be using HTTPS and not HTTP all the time. There's no excuse for HTTP nowadays. You might also be enabling HTTPS, in other words, blocking HTTP traffic over port 80 in the web application. And of course, web applications run on a web server, which in turn runs an operating system in a virtual machine. So you need to make sure that you always apply the patches of the operating systems and the web app server stack. Now, the integrity part of the CIA, we are talking about having the assurances of trustworthiness of the data. Has the data been tampered with, or is it in the original form? So we could do that by comparing hashes. Now, network integrity comes with in the form of digital signatures. A digital signature is created by a sender of a message or a network that is using a private key on the receiving side. On the other entities that verify the signature, that are related to public key, We have then we have two files with the integrity database. By comparing two previous hashes and current hashes to see if there is any change, it means that the data has not been changed or tampered with. Otherwise, if the hash values are the same, then the data has not been modified. Let's not forget that auditing, it's important too, and as part of integrity or assuming that the trustworthiness of a system, auditing system and the data on periodic basis. The last part of the CIA is the availability when it comes to the things like incident response, disaster recovery part. We get to the RTOs or recovery time objectives, RPOs, recovery point objective, and recovery time objective or RTO are related to IT services for availability. For example, we might have an RTO for a client facing public web application in 1 hour. That means that we can tolerate a maximum of an hour of downtime for the server, so the RTO would be an hour. RPO is more about data availability. For example, if you have an RPO of 6 hours, this means that you can tolerate a maximum of 6 hours of data loss and no more. And now another example would be to take on the availability of web application for load balancing. When a load balancer client connects to, for example, DNS server, which is like, for example, in this case, quick24x7.com, that would resolve, and the public IP address of the load balancer. The load balancer might be in physical appliance, it might be in a virtual machine, it might be in the cloud, it might be on-prem, or many variations of it. Either way, the DNS server and the interface of the load balancer is listening on the load balancer, and then it routes the client application request to the backend server is available and not busy. In our example, in our diagram, we have 3 backend virtual machines, so we might even have enable auto scaling, so that as we get more information, more and more client requests in a short period of time, which means the application is getting busier. We might even add more backend VMs dynamically as needed. They are called scaling out. Scaling in which the removing web application machines would be quite down if they're down at the moment. And in the cloud size, that is more important because you can save on the cost, and the most important stuff is that you're running it in the cloud as you pay, as the more you pay. So why have things running when they have not needed yet? So in confidentiality, integrity, and availability, this is the IT security triad. Security must be accounted for all these stages of the secure SDLC, or otherwise called as software development life cycle, and it applies to fixes after a solution is created. It is more difficult, it's more time consuming, thus more expensive. We are also talking about thinking about security, and it's the system design at the specs level where the system has originally been planned out. This means that taking into account any laws or regulations or contractual obligations that might require us to implement certain types of security controls as we develop solution. When it comes to programming, for example, software developers might adhere to security coding guidelines. We'll talk about that in a bit. And not just only for security, but for the entire SDLC needs to be documented correctly. Code needs to be documented. Any security controls that might be put in place that are outside of the code, but yet needs to be supported and needs to be documented. Then comes the evaluation and testing of the solution, and that might be done in a variety of ways, such as using a virtualization environment. Finally, the last part of SDLC in transitioning the solution production server after successful testing. And remember, testing will also include like fuzzing, vulnerability scanning, and making sure there are no security issues related to our solution. No security then must be applied to all the phases of the SDLC. So now that the software development and programming level, we have to think about code modifications and automated data deployment and those changes. So in step 1, when the software developer needs to make changes to the code, they check it out. Now this means that they've been using a tool that supports code checkout. Pretty much everything does these days now. Wherever you're talking about a cloning in the GitHub, you'd be using Visual Studio. You might integrate security control management, which actually also includes GitHub code checks or cloning repositories if you're using other software development environments. They support multiple developers like Jenkins. You can also check out the code by coding pipeline, though the eventual release of the tested code. So there might be malicious solutions for that. So the idea is to get the codes modified after it's been checked. So, but developers must follow the secure coding principles. They need to make sure that they are using only the trusted party components and libraries. The security controls must be put in place to prevent malicious code from being injected at this stage, so that the code gets injected out and the code gets modified. After the code modification have been put in place, the code is checked, backed, whatever the environment is used for, whether it's Jenkins, GitHub, or whatever the case might be. Then when the code is checked, it means that developers put potentially access to it. What we can, depending on the solution they are using, is automate that, and the code is being checked. It will automatically be tested. It will run through the number of pre-configuration tests upon their successful completion. Perhaps you can even automate the entire packaging activity by ultimately even deploying the solution. For mobile application, that might include sending push notification to subscribers and letting them know there's an application update available. We then have the notification from SecDevOps, Security Development Operations. Now, DevOps really combines software development, that's a part of the DevOps, and then going to the software operation of management, maintenance, or ops for operation. So this is all what DevOps is all about. It combines the items that result in a streamlined way to quickly develop and make changes to ultimately deploy the solution. And of course, security controls must be applied at all the levels: deployment, operation, maintenance. So if you're creating your own APIs, so if you're consuming or calling upon other existing APIs in web app code, you need to make sure that that is done over a secure network such as HTTPS when you're calling for an API. So you need to make sure that the trusted APIs and you don't contain any potentially malicious code. Secure coding means that number of things. This means that making sure that we can trap errors, runtime errors, and we don't use or disclose any too much sensitive information. We don't want to report back the versions of the database in the web server stack. We don't want to report the actual SQL query that might be used in the backend to retrieve information from the database. So be careful when you disclose the messages. Secure coding also means that thinking about whether or not you should be enabling session timeout based on the nature of the application. If you've been using for online banking, you might be familiar with the fact that if you're idle for say 10 minutes, you might have to re-authenticate. You might have to sign back into your online banking code and so on. For security reasons, session timeout might be something to be considered as a part of web application. Secure coding also means that thinking about what we want to use as server, whether it is through a URL, API call, web form, and we might have to think about the data type that we allow, such as string or a trigger character, an array, or whatever the case might be. In other words, we want to allocate only the exact amount of time required for the memory to validate input data supplied to the user. We might want to check it because we don't want to get into a situation where our application has buffer overflow vulnerabilities. Secure coding of course means that input validation, checking what was put in. If we are expecting a comment or field on a web form, that should be checking it on the string values, and we could then even do input sanitization, which could modify the user has supplied. If it's got special characters, for example, which should be stripped out, replaced with something else so they don't get interpreted on the server side, which could also lead to potential attacks. And then there are plenty of secure coding considerations, such as generating user session identifiers for each user sessions, keeping the sessions identified data hidden, so it makes all the data much harder for malicious user to hijack a session. We should forbid concurrent user activities with the same account, so we should configure the attribute cookie in our application with the dealing. This means that the cookie data that has been sent to web application server only with HTTPS and HTTP. Not on the cookie side, we can also use HTTP only cookie flag. This means that the cookie is designed to be sent over the server and manipulated server side. On other words, cookie client side code will not not have access to the cookie data, such as malicious JavaScript that might be running on the client side. We should always adhere to the principle of least privilege, and we should audit application access. So we know that software development includes a number of phases, coding and ultimately testing. You might even test your virtual environment in the Microsoft Azure cloud. That applications or web applications have deployment slot for the production of version of application, so there's no downtime for the user and application. But you have to separate the deployment slots from testing purposes. Ultimately, we would want to make sure that your environment is secure and efficiently and quickly delivered to the production, part of which you can also make that very efficient in automation. You can use automation things like code building stages and where you're testing before actually ultimately getting packaging and sending it out to production environment. These days, there are a lot of websites that are hosted in public environment, whether it's Amazon Web Services, Google Cloud Platform, Microsoft Azure, just to name a few. And so as a result, it is important that we are aware of the security controls that can be put in place, or the cloud environment or the cloud computing environment, including these hosted web applications. This is Cloud Controls Matrix page or CCM page for the Cloud Security Appliance CSA. Now I'm going to go ahead and download the Cloud Security Control Matrix. We could see over here that of the security controls or some security themselves, they should be put in place. Now, as this is being updated all the time, make sure you come here and go pay it a visit every now and then. So let's go down here on the version. Currently it's version 4. We'll fill it up and then questions, and you can download over here. So what I'll do is go and download the zip file. I'm just going to go ahead and extract it using whichever tool I have for zip extracting. I'm going to interested in the CCM Cloud Controls Matrix. I'm going to go ahead and double click on Microsoft Excel over here. CCM serves as the reference for the cloud technicians, which comes with securing cloud environments. So we have a number of worksheets in the bottom, including CCM. This is where we have control domains. The first one is audit and assurance, and the specific purpose that can be put in place, such as the independent assessment of each control and assigned to unique control ID according to the CCM, and it is accepted global standard for securing cloud computing. Now, for the control specification, I'll provide and go into further detail in this case, running development, audit, and security assessments, or at least annually. So there's quite some general, but it serves as a reminder that we can tweak to according to our requirements. As I go over it in the right, we can see where the responsibility lies in the cloud, such as the platform as a service. It says shared responsibility. This means that the cloud service provider, which controls the underlying infrastructure and hardware on which the hosted applications run, they are responsible for having the periodic security assessments, but shared means that the cloud customers are also responsible for conducting their own security assessment on services that are running on the cloud provider, on hosting services. As I go further down, we will get you the application interface security control chain. For instance, we have control title that states the application security baseline requirements. So the specification spells out that we should establish, document, and maintain the baseline security requirement for our secure applications. A baseline is a standard or the normalcy of what is accepted when it becomes when it comes to security application, web application. Maybe the security baseline that you would be set up for scanning web applications on the organization, that is directory listings that might be turned off for web application. HTTPS must be used, perhaps centrally authenticated requirement, or no anonymous web pages are allowed. So maybe it's a part of the security baseline. So depending on which type of assessment tool you run periodically will determine exactly what you specify in those situations. So you can correctly identify the outliers and non-compliant web application that need to be addressed right away because they fall outside the scope of the security baseline. Further down, we have the secure application design and development through the SDLC or secure development life cycle or phases, automated application security testing as well. We have touched upon this topic topic already. It could be such when the developers do a code checking for a code that are required to previously modify, and when they were checking it in, it automatically triggers a test, and if it test succeeds, it might even automatically trigger that component of the software that might be packaged out and made available. Maybe notifications sent to the subscribers for the application, so that at the very least the cloud control matrix or the CCM can serve as a good guide for reference point, and it gives us things to think about on how we might want to modify security policy and how it relates to cloud hosted web applications. An important phase of the software development lifecycle, SDLC, is testing but the reality is the testing should occur more than just during the SDLC. It should really be done whenever the code modifications occur. You should have periodic vulnerability scans, since the threat landscape changes all the time. With the web application security testing, we are talking about being able to identify vulnerabilities or perhaps sensitive information disclosure that wasn't a part of the design of the application originally. So security testing then should occur in a schedule. There must be different ways of testing, of which the static application security testing, otherwise called SAST. You could also liken this being essentially a code review, where the other developers review the code looking for flaws of some kind, including those that are related to security related. Then we might have a dynamic application security, or DAST. This is where a little bit different than the other testing of applications, while it is running and observing the behavior. And if you're thinking that sounds like fuzz testing, that we'll talk about about fuzzing a bit very shortly. The other thing when we are talking about the sandboxing in a test environment, is making sure it doesn't affect anything outside the testing environment. A few things like changes in the testing, the malware analysis, any code changes that have been done for tested. One aspect of it is having it placed in an isolated environment in the physical on premises or the network switch. That might even be the configuration of VLAN for testing purposes, or it could even be the virtual networks that is in the virtualization environment, not connected to anything else. Sandboxing usually requires the usual virtual machines, which can be spun up quickly, and when they are required in a Windows or Linux environment on a host application instead of the virtual machine. It might just be an application container which does not contain operating system on a virtual machine. In the Microsoft Azure cloud, we have mentioned that we can use application deployment slots for testing. You always have a production deployment slot running on the versions of applications, so there's never downtime and it's always up. It's running different URLs for developers who would want to connect to make sure that the changes to the application testing, and once they have been done and successfully been done, they go into production. You can swap out the testing from the development in a production one. So once testing is done, you have tested, becomes live in production version of the application. Now that we have said we are going through the first testing, fuzzing really means that we are sending web applications anticipated and randomized data, and in some cases even blasting it large amounts of information. The purpose of first testing is to see how the application reacts. We want to observe the results and make sure that the unnecessary changes in the applications, maybe to increase the stability or to reduce the sensitive information disclosure. We might even also tweak the configuration of our web application in the WAF or firewall policy. No one tool can be used for testing purposes in the OWASP Z attack or proxy or ZAP. This is a free tool. It does a number of things. So one of this is web application proxying, which means that you can proxy through OWASP ZAP tool. So you could interpret HTTPS transmission, you can modify them and send them to an application to see how it behaves. You can perform web application vulnerability scanning. You can perform web application first testing. Here we have a screenshot of OWASP ZAP tool, where we have conducted security vulnerability test against the web application, and On the left it's saying that we have an information disclosure issue, but of course we know that OWASP Zap tool can do much without just the vulnerability scan. The burp suite is another tool that you can use for all the things that OWASP Zap cannot do, and things like application proxying. Now there are community professionals and enterprise editions. The community is one is the free that you can use for testing web application. You can schedule your own scan, which you know is very important, and that could be triggered in a few in a build code, or it can be a scheduled concurrent basis. So having the automation trigger related to CI/CD environment, in other words, making changes and then checking the code back in the automated scan. Burp Suite can also generate a number of different types of reports in an environment with a visual format purposes and ease of digesting the testing results. Here we have a screenshot of Burp Suite specifically for Community Edition, which I've downloaded and installed. Now that we know we can run the vulnerability scan, we can do first testing. Here's the production application that has in the top has been selected and can intercept on the button on the selected. Now down below we have an open browser button. We could click on this one. Anything that we could do in the browser, like connect to a web application. First go to the burp suite tool for examination, possible alteration before sending it to a web application to test its response. So having some of these tools in your possessions, you know that to use them effectively is absolutely paramount in maintaining the security of your web application through testing. One great way to test the changes in the web application running in Microsoft Azure Cloud while keeping the production copy in the site is still running all the time in deployment slot. Now you can create more deployment slots for single web application. What you're really doing here is creating different URLs for web application so that developers could connect to a separate URL where you can then manage the code and the application and the contents that they make changes and test to it, all using the different URL in the production version of the website, which remains up and running. And all the users and web application developers and making changes and testing it elsewhere. So in order to do this, we need to have an existing web application in Microsoft Azure Cloud. Basically, it lets you have the testing and staging web application, as well as a production as well. At the same time, here's an Azure portal. We have left inside Navigator. I'm going to go down to application services. This is what the Azure calls it, web application. What this is running on being hosted on the Azure cloud, and now once you have which is called the web application app HYZ1. Currently the status of the web application is up and running. So if I click on the properties and it says if I click on the browse button, it opens the web browser with separately where it shows me that the pages of the web app. Now not every web app is going to the home page and the user interface. Now you might run into some kind of background service and web application components. So this one is up and running right now here. Also it is accessible over HTTPS by default. So if I could stop on the website, restart, delete it. However, if I want to do it here on the deployment side of the deployment slots, the production application version of the application, its own deployed, it's called its own slot. So no surprise here, it's production. So here now let's deployment slots, and that's fine. But if I want to add any new deployment slot, because I have to need to make changes in the web application periodically, maybe update the features and bugs, whatever the case might be, and I don't want to bring down the production version of the web application, the tester implement those. So I'm going to go back and click on the add button over here. I'm going to create a slot for testing. Now I'm going to go this and create a URL for essentially a different web application, and the new URL will include the new slot. So the web application is called here as web app HYZ1 and normally DNS suffix with Azure websites.net, and that's by default. You can even use a custom DNS name, but that's a different topic. But what happened here is if I name the web application as a DNS level to web app HC1 testing is the name of the new deployment, and then the Azure suffix Azure websites.net follows. So in a different DNS name, we are going to be saying that we can choose the clone settings from the production version of the web application, things like database connection strings and so on if required, but it is a very basic web application. I'm have them, so I'm going to go in clone settings and I click OK and add successfully created my slot in the time is testing here. I'll click close now and the testing goes below, so the web application testing is up and running deployment now. Currently 100% of the traffic is going towards production URL of the web application, the production version of the application, so that the software developers can then go ahead when they want to make some fixes on the bug, add features to web application so that they could be doing it in testing slot. When I click on the link over here, name of the slot over here takes me into more properties. I get a new navigator on the left, and it is important to take note of the fact that it's on the application service or what it's called, and it's in the parentheses slot. And of course we have our name over here, and the overview section we will be selected in the left one side of this. On the right, notice that the URL in deployment slot, which includes the name of it, that is /testing, and also the browser. We can also do our web application testing on the deployment slot, and of course our production web app is up and running now. Now that we could do, our developers who are connected to the URL, the deployment slot of the web application, make changes to test them, and they are satisfied with the changes for they're already in the production, and what you can do to use the swap up button to swap the production default slot with the testing one. So in testing slot we are working over here, and we are changing and testing thoroughly. Will become the new version of the production slot, new version of the web application, of course. So we now click on swap over here. The target will be a real production slot, the production slot. If there were any source or target config changes, that would be shown in the summary or down below. I'm going to go ahead and click on the swap button. Okay, now quick access is here and easy. We have a message that states successfully completed. The swap button has been slot testing and slot testing purposes, and this is all transparent to the users of the application. They are still connecting to the URL they always did. So if I go back to web application, the production of web application slot, which is currently running now, would reflect changes made to the testing slot because it's been swapped out of the slots. Now this is a great way to deal with testing and to minimize downtime of a web application. The OWASP Enterprise API, otherwise called as the ES API, is a free coding tool library that can be used by developer software by either building a new web application, or you might go back to the retrofit an existing one to add some secure coding to it. The idea is that we use this for new and existing web application to make sure that they are as secure as possible. You might say that this is a general statement, but what does this mean? Well, one of the many things include input validation sanitization, because really you can run vulnerability tests against your web application. You can have periodic code reviews or penetration testing, but that's not all that you should be doing. The code itself needs to be written in a secured manner, which means doing things like input validation and sanitization, making sure you allocate the required amount of memory variables. Now what's interesting in the OWASP ES API is that it's available in a multitude of languages. So if, for instance, if you want to be writing in the code for a Java server side, the ES API now will not be available for you to download in GitHub. So we have the ES API for Java Enterprise Editions EE. So in order to use, you would have to have Java version 7 or better. Now ES API itself receives periodic updates, so you can, or you should be checking that for sure. That has been constantly made improvements in the code and libraries, and call upon the web applications to make more secure. But it is more than just the input validation sanitization tool. The ES API gives you support for logging in, cryptographic operations, and of course user input filtration. Pictured on the screen, we have got a screenshot of some Java packages available to the ES API. Notice that the version over here shows ES API 223. Bear in mind it gets updated, so each of these listings, such as over here the page OS, first page as org OWASP ES API is the package that you want to import from the Java code library. This exposing things like methods available when in your package is kind of like importing a code library, so you can use it within your code. Notice further down over here in the crypto type in the API Java package that we call upon, we have now got one of the errors. We have got a few logging part here. This part is a bit is a learning curve to make sure that we know how to make the API calls when using ES API, but that's all a very well documented public library. So here's what we got: an example that might use as ES API with the input validation and importing one of the listed below here. Now we are going to now we're going here is when we are basically trying to validate the first name and last name using ES API validator construct. We're trying to get input validation, and we are giving it the names of the item. Save string is essentially a regular expression here, which what that tells it the input validation or valid input method is what we essentially want to allow things like alphanumeric characters or white space characters. The 30 within these calls are referencing to the maximum length. The word false here means you do not allow null values. In other words, first name must be supplied as well as last name. You could customize how it looks like, but this is making straight call and get input validation method, and that's a part of the ES API library. You could also continue with other variables like email address and so on. Now we have the ES API node.js and node.js, of course, to confirm the JavaScript, but it is not limited to the JavaScript or it's running within a web server. It can even run regular site as well, but in this case we will run an ES API variances for a variety of different languages. Where they get updates. They should be patched periodically with those updates, as we know that we have a number of packages here, so that we are writing the code in our related to logging, crypto, or user input or filtering. So there are a lot of commonalities when the ES API across languages. The only real difference being the syntax. Here we have a screenshot example for documentation for the data sanitization through ES API, and what's important for the software developers of course over here is taking note that what we know, data must be passed to a function like a string value of the context or string value and actual input, and then put it down to the bottom returns. What kind of data is returned here for data sanitization? We have been told that has been passed for a version of the input or default value will be returned, so stripping out the characters here, but the key is referenced in the document. Ideally look at some examples to do some testing to get rid of get used to how these ES API when writing the source code. So in this course, we've examined how to ensure that the design of a web application includes business requirements related to the security controls. Also, by this exploring the CIA Triad and SDLC and CCM, we discussed various types of software testing. We managed various application deployment slots. We also discussed the OWASP ES API for secure programming. In our next course, we'll move on to explore how to detect security misconfiguration and also how to deploy solutions to remediate these weaknesses.